So we're going to start with the integration today. So the first thing, guys, you have to remember that integration is totally the reverse process of the differentiation. For example, if you are going to differentiate x square, okay, when you differentiate x square, you get 2x. So remember, if you, this is the sign of integration, you have to write that whenever you have to integrate. This is read as the integral of 2x with respect to x, 2x dx. So all of this is read as, this integration sign means the integral of 2x, dx means with respect to x, okay? So this will be equal to x square. This has to be equal to x square. And we have to write a plus c with this. I'll tell you that why do we write this plus c later, okay? Now suppose you are going to differentiate this, let's say you have 3x square plus 5x, sorry, plus 5x, and then there is plus 2, okay? When you differentiate this, you get 6x plus 5. You get 6x plus 5. And now if you integrate this 6x plus 5, all of this, when you integrate this, this should be equal to 3x square plus 5x and then plus c. Now, let me introduce you guys the first rule of integration, that if you people are going to integrate x raised to power n, this becomes x raised to power n plus 1 over n plus 1 plus c. That is a very first rule. This is against that first rule of differentiation, where you have learned that if you differentiate d by, like you want to differentiate x raised to power n, you get n x raised to power n minus 1. Okay, now look at this. If I write this n x raised to power n minus 1 and I add 1 into it and I divide it by n minus 1 and then plus 1, you see I'll be getting this x raised to power n back. Look at this. This would be x n x raised to power n over this n, and you get this n back. So basically, whatever the power you have here, like right now, this was the power n minus 1. So you're adding 1 into it and divided by added 1 into the power. So you get your whatever that was differentiated, that expression is brought back, okay? So look at this, how this 2x once again becomes x square, because if you apply this rule here, this would be 2x and the power 1 plus 1 over 1 plus 1 and then plus c. So this is going to be 2x square over 2 plus c, and you get this x square back, okay? Similarly, look at this one, this 6x. This is going to be 6x square. The power is 1 here. When you add 1 into it, you get 2 over 2. And you have 5x is to power 0 here, hai na? 5x is per 0 because it is just 5. So this becomes 5x is per 1 over 1 and then plus c. I can tell you that why do we have to write this plus c now? Look at this. This 2 was eliminated during this differentiation. You had three terms. You had 3x square, you had 5x, and then you had plus 2. When you differentiated, the derivative of 3x square was 6x. The derivative of 5x was 5. And then there was a plus 0. That was for the derivative of 2. So this means whenever you will be integrating, whatever you integrate, you will you will have to write a plus c for that constant, if there was any constant and it got eliminated during that differentiation. So for that we write this is the atma of that constant that got killed during the differentiation. Okay, so
Yeah.
Vacha, this is the very first technique of the integration. Now let me um, try these questions for you people quickly, and then you will be doing them yourself. Okay. Now, as you people, since you people have already covered the differentiation, and this is very much, this resembles a lot with the first technique of differentiation. So when you people were applying the first technique of differentiation, whatever you had, whatever was the expression, you had to get rid of all the products or the quotients, and you had to write your expression into the most simplest form. Okay, so we are very happy to integrate this 4x is per 7. This is a part here, one part A. I'll be doing all these parts and then you will have to do all of them once again. So this will be 4x raised to power 8 over 8 plus c. Now don't worry about this 4 that is just being multiplied with this x, okay? If it was 4 plus x raised to power 7, then there was something to worry about because now these are two terms, so its integral would have been 4x plus x raised to power 8 over 8 plus c. Anyhow, this one can be written as x raised to power 8 over 2 plus c. So this finishes here. Now, similarly, look at this C part now. In the C part, you have 2x is per minus 3 dx. So this is 2x is per minus 2 over minus 2 plus c. Okay, so this is minus 1 over x squared plus c. When I cancel this 2 with the minus 2, I get minus. And when I move this x squared to the denominator, the power becomes positive. Okay? Now you look at the D part now, bacho. Now this the D part is 4 over x squared. Remember, um, you should have been told in your differentiation that you people are not allowed to differentiate anything in the denominator. Similarly, you will not be integrating any expression which is there in the denominator. First, you have to move that into the numerator and you have to write that in this form x raised to power n. Only then you can integrate this, okay? So I will not be integrating this until and unless I have this in the required form. So I'm going to write all those signs of integration because I am not performing the integration right now. So now this is in the form that we can really cook this up now. This is going to be 4x is per minus 1 over minus 1 plus c. And then I can write it as minus 4 over x plus c. 4 over minus 1 is minus 4 and x to the power minus 1 goes to the denominator. So this is going to be minus 4 over x. Okay? Look at this E part, part E.
Sir,
Yes, yes. Mhm.
so do we just leave the C or are we supposed to find out what C is?
Yeah, that you will learn that in the applications of integration. You will have to find that value of c. In fact, this is this exercise 15.2. The integrals that we're finding right now, these are called indefinite integrals because we do not know that what is the value of c over here. ठीक है ना? So if you people are able to find the values of c, then they are called the definite integrals. Okay. In fact, you will be finding the c to basically find the equation of the curve. Okay. Definite integral is something else where you apply the limits. Anyhow, this is it. This is the final. I mean, the answer here. You let this c be there as it is. Okay. Okay. Now look at this e part. Now this e part is. I'm sorry for this color being very light here on this red background. Okay, so this is your 3 over under root um, x dx. Okay, so I will not integrate this right now. I'll first write it as 3x to the power minus 2 minus half, sorry. And now I can integrate it, okay? This is 3x is to power. Now minus half plus 1 is half. And minus half plus 1 is going to be half. Okay. And then plus c. And finally, this integral is 6. 3 over half is 6. And I can write this as under root x. And here it is plus c. 6 under root x plus c. Okay. Now, Look at this f part. Let me cover this up here. So we are basically practicing the very first technique of integration. Okay. So part F. So this is 6 over x square under root x dx. Acha, no products are allowed here in the integration. Okay, so I will first of all write this as 6 over x raised to power. This is 2 plus half. Let me write this as 2.5. I can use the decimals as well. Okay, now this becomes 6x raised to power minus 2.5. Okay, because this has to be there in the numerator. You cannot integrate the things which are there in the denominator. You have to move them until and unless this is like impossible to be handled. Okay, and that will be your P3 A levels integration. In your additional mass, you have to move whatever you have to the numerator. Okay, so now this becomes now 6x, and when you add 1 into minus 2.5, you have minus 1.5 over minus 1.5 plus 6. See, and this is going to be minus 4 over x to the power 1.5. Okay, or the smarter ones can write it as x under root x as well. ठीक है अच्छा बच्चों, if you forget to write plus c here, you should, for example, if you don't write c here, you should remember to write c in the very last step. Okay, but you should write this because you might lose a mark if you don't write this plus c. ठीक है, now look at this question number 2 part A. In this question number 2 part, remember there is no u dot v, there is no u by v in integration. Okay, integration has got its own rules. Okay, so in this 2 part A, we are not allowed to integrate the products, so we have to expand this. Okay, so when I expand this, I'll keep on writing all of these symbols with this. This is x squared plus 7x plus 10. And now I can integrate it. Okay. So this is going to be x cube over 3 plus 7x square over 2 plus 10x plus c. Since there's no more simplification required, so now I can write plus c with this. Okay. Similarly, if you look at the part D, maybe part D, you can do that part C later on by looking at the way I'm doing this part D. Okay. Now look at the part D. Let me cover this first. Um, Here we are. Okay. Uh, the part D, 2 part D. Now it says the square root x plus 3 whole square dx. Again, guys, you have to simplify this. No powers in the brackets allowed in integration, okay? Especially in the first technique here. So when I expand this square, this is going to be x plus 6 under root x plus 9. Okay, and now I will be writing this as x square over 2 plus 6, and this is basically x raised to power half. So half plus 1 is 3 over 2, or 1.5 can also be written here, over 3 by 2 plus 9x. I don't want to write plus 3 right now. This is x square over 2, and this is going to be 4 x to the power 3 by 2. This is 9x, and here is the plus c. Okay, one more part, and then you will be trying these questions yourself. Part F, it says 2 part F here. The cube root of x into x minus 4 dx. Okay, I have to expand this. I'll keep on writing these signs. This is going to be x is to power Cube root of x means x to the power 1 over 3 multiplied by this. That will give me 4 over 3 and minus 4x is to power 1 over 3. Remember, bacho, I'm repeating again and again. There should be no products. There should be no quotients. There should be nothing in the denominator. I mean, that variables, no variable should be there in the denominator so that you can integrate this through the first technique. So now you see that these are bilkul sharif aadmi ban gaye, and now you can integrate them. This is going to be 4 over 3 plus 1 is 7 over 3. And now I can write it as 3 over 7 because you know the reciprocal of 7 over 3 is 3 over 7 minus 4 x raised to power 4 over 3, yes, times 3 over 4 plus c. I hope you people are not confused with this, whatever I have done here. Basically, it was x raised to power 7 over 3 over 7 over 3 minus 4x raised to power 4 over 3 over 4 over 3. So over 4 over 3 becomes 3 over 4. Over 7 over 3 becomes 3 over 7. Okay? So now you try all these parts of the question number 1 and 2, and then I'll take the third question. Acha, since we are practicing the first technique of integration, that is x raised to power n dx, that is x raised to power n plus 1 over n plus 1 plus c. Okay? So remember, you must have your expression where each term is separated from the other term with only the plus or the minus sign. There should not be any product, any quotient, any fraction, any whole powers. Okay? So look at this 3 part A. How would you do this question 3 part A? Since there is no u by v in your integration, so you have to see how to split them. This is x square minus 5 over x square. Remember, bacho, we can write a plus b over c as a over c plus b over c. And at the same time, you should remember that a over b plus c cannot be splitted further. Yes, you can write it as a into b plus c whole to the power minus 1, but this cannot be written into these I mean as a sum of two different fractions here. Okay? So this is the case where we can split them up as, we can write them as x square over x square minus 5 over x square. Okay? And this then becomes 1 minus 5. And let me move this x squared to the numerator here. Now, this is the form that we can integrate. So integral of 1 is going to be x. Okay. Remember, the derivative of 1 is 0. So the integral of 1 is going to be x. I think I didn't emphasize much on this. If you have to integrate x squared, this becomes x cube over 3. Okay. And if you integrate x, this becomes x square over 2 plus e. And if you integrate a number, a constant, let's say there's just one here, like, you know, just it is just dx. Imagine there is a 1 here. So that would become x. Okay. And in general, if you're going to integrate a constant, let's say this is a dx. So this would become ax. So similarly, the integral of 1 is going to be x. And then you have minus 5, x is to power. Minus 2 plus 1 is minus 1 over minus 1 plus c. And finally, this is x plus 5 over x plus c. That is the integral of this 3 part A. Okay? Now, let me do this uh, quickly, this F part. Maybe before F, I should do E part, let's say E part, okay? It is going to be, I'm going to do the first step here. This is x raised to power 5 over x cube under root x plus 5 over x cube under root x, okay? We write it like this first of all. This is cancelled by this. So you have x raised to power, since there is x in the numerator, there is x in the denominator, the powers will be subtracted. 2 minus half is going to be 3 over 2, है ना? This is 3 over 2. And this one is going to be 5x. Now here, this 3 plus half is going to be 3.5 over 7 over 2. So this will be minus 7 over 2. And now, guys, you should be very good at these simple simplifications. So now I can integrate it. So this is x is to power. I add 1 into it. I get 5 over 2 over 5 over 2. Okay. This is 5x is to power. When I add 1 into it, I get minus 5 over 2. है ना? This is minus 5 over 2
Sir,
over
आपने इसके अंदर माइनस वाला साइन क्यों नहीं लगाया in the power when you brought it up?
this one here.
Hmm.
Whereas this was 2 over here. This is 2 and then minus
Oh,
half.
oh,
2 minus half. That
okay,
is 3
thank you.
over 2. Okay. Because there was already an x here in the numerator. So I had to simplify those powers. Okay. So this is going to be minus 5 by 2 here. And then there is a plus c here. Finally, this is 2 over 5. X raised to power 5 over 2. This one is, this 5 is cancelled by this. This is minus 2 and over x is to power 5 by 2, and this is plus c. That's it. Okay. So
यार जो ऊपर -7/2 है वो कैसे आया? Because wasn't it 3 and then 1/2? So I
no,
don't get how.
no. What is 3 plus half? Hmm? Isn't that 7 over 2? Hmm?
Oh, okay.
Yeah. And
Okay.
when you move it to
Sorry.
denominator, okay? Okay.
Yeah,
So,
okay. Thank you.
okay, no problem. Acha, bacho, now just one more part. I just have 2 minutes with me to complete this, just to tell you how to do that F part. Okay? Okay, this F part. So in this F part, let us do this F part here. This is under root x plus 3 over x raised to power. Let me write this as 2.5 or 5 over 2. Okay. And then there is a square on it. Let us open the square. It is going to be under root x whole square plus 2 under root x into this 3 over, let me write it as it is, x square under root x, and then plus 3 over x square under root x whole square. This is your a square plus 2ab plus b square. So this is going to be x, under root x cancel with the under root x. You have plus 6 over x squared, and then you have plus 9 over, this is power 4, this is 1, and this is going to be 5, है ना? X is to power 5. So when I have to integrate this, I will be writing it as x plus 6 x is per minus 2 plus 9 x is to power minus 5. Oh, I have just less than a minute. This is x square over 2 plus 6x is minus 1 over minus 1 plus 9x is minus 4 over minus 4 plus c. And finally, this is x squared over 2 minus 6 over x minus 9 over 4x is over 4 plus c. That's it. That was the practice on the very first rule of integration, the first technique of integration. Okay.